My name is Trey. I work with IRIS National Fair in capacity of program manager. A warm welcome to IRIS webinar on environmental engineering. As you all know, this year we have introduced certain new subject categories in IRIS. Environmental engineering is one of them. Our sole purpose is to, we want students to focus on individual subject categories. Till last year, we used to have 17 categories, which is still good. But now, since we have introduced 4 new categories, it will certainly help you to bifurcate your project into right perspective and right subject area. Thus, I would like to begin with what is IRIS. Initiative for Research and Innovation in STEM is a platform which provides you an opportunity to recognize on the world stage. We inspire you to research and innovation in the field of science. IRIS guides and mentors you to improve your research-based project. IRIS, we invite students to participate in IRIS with a research-based project, something which is novel, which has never been done by students before, or something we would not say uh, a new invention, but something which has been done before, but you are bringing your own innovation in it. Our objective is to stimulate young minds to take an active interest in science and technology, and we want you to use research as a tool for creating new knowledge and build a strong scientific temper, so that going onwards, when you grow up, you undergraduate, you go to your you do business or you do any job, you use science as a tool, research as a tool, and work more effectively. The annual timeline of IRIS, this is the time when we reach out to students and we ask you to work on your science-based project and submit your entries, which are not yet open. We will be opening our entries very soon, and submit your project to IRIS. Once you submit your project, we have a panel of scientific review committee, which does project shortlisting and evaluation. From those bunch, we select top 100 projects which represent in IRIS National Science Fair, which happens once a year. Last year, we conducted our national fair in the month of January. This year, we are waiting for this pandemic to end to decide whether we will be going ahead with the national fair online or a exhibition session. IRIS, with its coordinators, we reach out to a lot of students, teachers, schools every year. Till now, we have touched over 4 million students and we are counting. This is very, very important for all of you, the eligibility to participate in IRIS. We allow students of Indian origin from schools based in India. Please notice the point, schools based in India. There are schools, there are CBSE schools which are outside India as well. And there are students who are Indian but studying in schools, in CBSE schools which are not in India. Those students are not eligible to participate. Hence, we have written very clearly, students of Indian origin. Also, if there are international students who are studying in India, they can be, they can be of son or daughter of, some working professionals of international people. They are not allowed to participate. Only students of Indian origin are allowed to participate, and those are from schools based in India. You can participate in 2 categories. One is junior. In junior category, it's for 5th to 8th standard students, and senior category is for 9th to 12th standard students. Junior category students do not compete for ISEF. They win awards, but special awards in IRIS, and they get an opportunity to get Broadcom Masters Award. Broadcom Masters is basically a award. We select only one student, which goes to an international platform along with Team India. Team India basically are the winners. who win grand awards at IRIS. And Broadcom Masters winner also go with the team, but they have their own session at ISF and do not participate or compete in ISCF per se. The senior category student are 9 to 12 standard students. They are eligible for special awards as well as for grand awards. And the grand award winners, they go to ISCF. They represent as a team India. The students who have completed their class 12 board exam are not eligible to participate. This, for example, this year, the 12th grade students who have given their board exams in the month of March, they will not be eligible to participate. With IRIS, if you are a undergrad student or you are a IRIS alumni or a teacher, if you would like to volunteer with IRIS, you are welcome. You can send us emails or you can visit our website and register yourself as a volunteer. And you can support us in conducting our events when we do. For example, we do IRIS National Science Fair, we do partner fair meets, we do workshops in schools. You can support us in doing the workshops and volunteer with us. Mentoring is only for the teachers or professors which are who are available and dedicate their time in voluntary work and support students in mentoring, guiding students. There are a lot of students in India and they also contact us that they are not able to find right mentors for their project. You can register with us and uh, you can be a part of mentoring team of IRIS. Then the collaboration is for the people who represent organizations, uh, which can be government or private organizations, and they would like to sponsor IRIS or they would like to participate or support students in their projects. They are welcome to join us. Hence, I would like to firstly welcome Professor Dr. Anupam Kumar Singh uh, for joining us today. Uh, Our expert, Dr. Singh, he works with Indus University, Ahmedabad, in capacity of Director, Indus Institute of Technology and of Engineering. He has completed his doctorate in civil engineering from Karlsruhe Institute of Technology, Germany, and has over 25 years of experience in academics, administration, and engineering industry. Dr. Singh has completed integrated water resource management, environmental engineering, infrastructure planning, GIS, and remote sensing application, and has many books published by him. I would like to welcome Dr. Singh.
Thank you, Shrey. It's a pleasure actually to be with all of you, and it's indeed a pleasure to be with all of you. I would just take a minute. I would like to share my screen with all the students who are. Yeah. Oh, wonderful. Yeah. Thank you. Yeah. So let me, begin by saying that it's a great pleasure, actually, for me personally, to be with school students because I often teach college students, I teach engineering students who are at bachelor's level, who are at master's level, who are at PhD level. So it's indeed a great pleasure, actually, to be with these the modern citizens of this country, and I really actually for this opportunity. I would like to put on record my thanks to Iris, Mr. Shreya Singh, who contacted me very early, and also Shasha Kumar, actually, for this one. This presentation is just a tool to for all of us not to go out actually of the way, but you all are free to stop me anytime if you like, or you can ask me question at the end. So the agenda for today's, next one, please? Yeah, so today's agenda is that I would like to talk a little bit about the environment and, the sustainability and how various sub areas of this environment are playing a crucial role actually for human habitation. When we know that, this COVID has happened very recently, and we know that this is not sustainable. We also know that it's putting a lot of barriers on our movement, not only movement, on our thought process, on our development, on our psychology, and also many times on our capabilities. So therefore, actually, I would like to show you something, mainly relevant to India, that how this is unfolding and what are the how can I work, or if I work in the other area, then how can I work? Yeah, so I would like to talk a little bit more on that. I have unfortunately not done much on land reclamation, but I think at the end I would like to discuss about that further. I will also give further idea that how to develop uh, because majority of the projects which are being developed right now in India, unfortunately, are not converted into a real prototype, or sometimes prototype, then not in terms of opportunity to convert, those uh, ideas into prototype and prototype into product. And we have very strong now Indian Patent Act system, under which some of you could again, try to convert this idea into your own name, for at least next 20 years. And then there are few ethical issues, related to doing something or other. So I would like to talk that as well. And finally, I will be, open for question and answers. And next one, please. Yeah. So when we see the sustainability, we are often so-called confronted with daily reality in terms of so-called, certain problems that society is facing. Now, when we talk about sustainable development, we say that sustainable development is the development, which is doesn't compromise for the people who supposed to come during, some point of time, let's say later. So this means if you are a school student, maybe let's say you are going to live 100 years. Yeah, so this means next 80 years, whatever the resources that we are having today, those resources must last for all of you for next 80 years, or maybe next, let's say, I don't know, 85 years, right? This will happen only when we are conscious about today's need, and when we are conscious about uh, issues, which are there, So, where is the presentation? I'm unable to see the presentation. Uh, can you see the presentation? I am unable to see the presentation actually.
Yes, sir, it's live.
I don't know what has happened actually, because I am unable to see that actually. So, nevertheless, I have mine own. Yeah, okay. So therefore the development has to be like that. Yeah. And in other, there are certain constraints in that development, And one of the major constraints that we are facing today is resource availability. And also second constraint, that we are facing in terms of upkeep of those resources. So when we talk about environmental engineering, pollution is normally one thing which comes to the mind of everyone. And I would like to focus mainly here on one parameter, which we call it air pollution. Now, many of you have studied in your, let's say, 9th, 10th, 11th, 12th standard that pure air is a combination of nitrogen, oxygen, and other gases. So we say that nitrogen is approximately 78%, oxygen is around 21%, and the other gases which are there, they are almost 1%, but are in a part of the frictions. And mainly I have written there, it's argon, carbon, neon, helium, and like that. So what is happening when the concentration of these 1% gases actually changes? What happens that our air actually become polluted. So even a small fraction of that can deter the air quality. Now, next one, please. Yeah. When we are measuring actually this ambient air quality, and I have brought some standards because there are often some standards. You need not to worry about these numbers. Just try to understand that there is a upper limit actually to these standards, and there is a lower limit actually to these standards. Okay, and these standards many times are either measured hourly, or they are measured 8 hours or 12 hours or 24 hours, or daily, monthly, weekly, annual, like that. Yeah, so therefore we have to make sure that whatever the standards are there, actually we are able to meet standards. Now, reason for meeting these standards is uh, that most of actually the level has been kept in such a way so that these standards meet the sustainability criteria. That's point one. Yeah, so I have mentioned in the beginning that development must be sustainable, and therefore if everything which is remain within the limit, below this limit numbers which are given, then if it remain below that limit, this means the development is actually a sustainable development. Okay, and therefore each country has these different standards. India has this kind of standards. If you go to Germany, their standards are approximately 25% better than our standards. If you go to Sweden, you will realize that their standards are maybe 30% better than our standards. Yeah, next one, please. So when we look this air quality, air pollution we call it, air quality you can say, because we are representing air pollution in terms of air quality. And I have told you that balance, in terms of nitrogen, oxygen, and other gases which were there. Yeah. So in India, if you see, this is an Indian map, and you can very well see here that I have divided this entire India into different clusters, right? So we have a cluster. Let's say if you see the cluster one, which is, we call it NCR cluster. This means National Capital Region, consisting of Delhi, Faridabad, Ghaziabad, and Loni, and that entire area. So this is one of the worst polluted actually cluster in India. Then we have another cluster which is in terms of the so-called in terms of industrialization. So we can say that this is Amritsar, Ludhiana, Chandigarh cluster 2. Cluster 3 again, when we take is, we can say that it's like a Gangetic Plain cluster, starting from somewhere Agra and goes until Banarasi, a little bit further down. Then we have a fourth cluster, which is Rajasthan cluster, like Jaipur, Ajmer, and likewise. And then we have another cluster, which we call it Gujarat cluster, where Ahmedabad, Baroda, Bhopal, Indore kind of. And then again, there are clusters just for the purpose of demonstration, took this example so that it is possible to see that, how we can classify this air pollution in various areas or in various cities, and then what kind of technologies which essentially are required in order to sustain our livelihood. And those who are living in NCR, they can very well, comprehend and, can also tell that there are, days or even weeks, when we have a difficulty in breathing actually. Now, if somebody has a difficulty in breathing and, these air pollutants are bigger one, they normally go into lungs and health system, and then therefore, create one or other illness, either in terms of asthma or in terms of other, so there is a very strong actually relationship between air pollution and human health. And therefore, at city level, at cluster level, what kind of things are required, what kind of technology are essentially required, we can think for those, and then we can, develop them. Next one, please. Again, when we see the air pollution cases and exposure, I will not go much into this one, but this is there actually. And the idea here is that, because of agricultural activities, as I'm mentioning, especially the biomass, when they are burning that biomass in Punjab and, in Haryana or in parts of UP, this air comes to Delhi, because Delhi is a big city, and being a big city, the temperature is low, and once temperature is high, and when temperature is high, it creates low pressure. And when low pressure is there, that the air moves from high pressure area to the low pressure area. And therefore, all air, which is in the surrounding area comes to actually Delhi. Yeah. So that is one reason which I can actually give you. The next one, please. Yeah. So there are some technologies for air pollution control, and these technologies are, one could make a small, for example, cyclone. So you see that cyclone is a very simple system, yeah, where left hand side you have a dirty air, which is entering into this cyclotron, yeah, and this air moves so-called into one direction, and once this air moves, then what happens? These small particles which are there, through a colloidal process, actually, they becomes bigger one. And since they are bigger one, they are heavy. And once they are heavy, then they precipitate down in the form of dirt. Yeah. So therefore, in this cyclotron, the separation process actually of the dirty air and the deposition of semi-solids or solids actually takes place in the clean air, which is normally now lighter air, goes in the atmosphere. Yeah, so this is one process. Now, there is a possibility to actually improve the design of this cyclotron, because normally this is a simple, funnel kind of a thing. Yeah, but I think if there's a possibility to so-called devise, a new cyclotron based on the principle of fluid dynamics, we call it, yeah, and therefore it is possible to remove even these. You see here, I wrote that the solid pollution control, this particle size is approximately 20 micrometers in size, and this removes approximately 90%. Now, 10% still goes in the air. Now, whether it is possible to improve the so-called efficiency from 90%, say maybe 95%, yeah, then we can win a lot of cost actually, yeah, and also the cost in terms of air quality, yeah. Another example I'm giving you is shower. So what is happening that the mist actually here in this particular experiment, what we do is that we are bombarding the mist actually in the form of droplets, yeah, and these droplets are really tiny droplets, yeah, and these droplets together with so-called these, air, which is again with the suspended solids, yeah, and so they together come and they form a bigger droplet, and therefore they fall down. And that's why students can see that when there's a rainy season, our sky is much cleaner than the sky during the summertime. Yeah. So this is the reason. And therefore we have the shriver kind of thing, which is very often used, even for example, in Delhi metro, they use actually so-called this shriver technology for cleaning the railway wagon. Yeah. Or, this metro wagons. Yeah. So such things are again available. Next one, please. Now, another technology is actually, we call it bag house. So this is very similar actually to technology, which is, I already told you, this is very similar to cyclone kind of a technology. Again, where we have a different compartments, and then we have a medium. So medium means filter medium. So for example, if you see, you have a tea, and when we have a filter, actually we can put filter and pour actually the tea into that filter, and particles which are bigger than the filter size are often collected in those smaller particle size. They are actually bent normally through the sea. So what we can do is that in order to increase the efficiency of collection, we have to minimize the size of pores of this sea. Now, if we have to minimize this size, what will happen? Actually, the efficiency, the volume of actually goes down, because if the flow which is supposed to happen through these open, pores, the pore size is decreasing, then flow actually is decreasing. Yeah, its pore size is decreasing, the flow is decreasing, and therefore the possibly the efficiency of such normally things goes down. Yeah, so therefore we have this technology. Again, if you see that the removal efficiency of this technology is again very close to 90%. Now, can we do something, because these devices are having huge cost in terms of, and they have a huge balloon, because each and every industry now, as per the state pollution control boards. I am from Gujarat, so we have a Gujarat pollution control board. Those who are from Rajasthan, we have a Rajasthan pollution control board. Or Tamil Nadu is a Tamil Nadu pollution control board. And then we also have a central pollution control board, actually, yeah. So what happens that these people, they make sure that, the certain standards are very well met in order to actually work with, yeah, these devices. So one can have a multiple compartment, so that one can easily the volume filtration which is there. Yeah. So I think there's a possibility that one can do something here in terms of these air pollution control technology. I thought that I will try to bring you, one important sketch here, and this is sketch is a typical problem, that majority of us are facing at a thermal power plant. So this is a typical thermal power plant, where coal is being crushed and also then fed into the boiler. The water is being circulated actually in the boiler, and we heat that water, we make steam. Now that steam rotates actually the turbine, and turbine rotates the generator, and therefore we convert actually so-called this coal energy into actually the electrical energy, and then through a transformer we supply this to the grid. Now if we see here, in this particular process, is we are very much aware that these thermal power plant produce a lot of actually air pollution. So is it possible to do something as an integrated project actually for these thermal power plants? So for example, what is happening that when we are boiling the water, yeah, because water is being generated into steam, and that steam is being so-called actually recirculated, yeah, through the cooling tower. So we have a cooling water. So this means a hot water need to be once again, cooled, and then again it has to be actually supplied, yeah, because the condensers are there, yeah. So what is happening actually, if you see typically such thermal power plants, the efficiency is normally low. I mean, it was as low as 40%, which in the years has improved actually, and goes as high as two-thirds, this means around 65 to 70%, like that, yeah. So there is a possibility that this steam, yeah, which is at, let's say, 110 degree, 120 degree centigrade, we can convert actually, this steam, because the delta is very high here, because normal general water, I mean, the normal water has a temperature approximately 24 degree to, let's say, 30 degree here in India. So if your steam is at 110 degree, the gradient is approximately 70, 80 degree. Yeah. So this 80 degree gradient can be very well utilized actually for the purpose of so-called, we call, heat recovery. So we can use this heat issue either into a system, for example, in, let's say, in Europe, a lot of houses are being so-called centrally they have central heating system. Yeah, in India also, actually, right now, we have those inverter, uh, we call them, refrigerators now, systems which are there. So there's a possibility to use this heat actually for some purpose, and therefore I will, suggest that some projects can be developed in that area. Then again, actually what happens that this coal has a lot of obnoxious gases in terms of nitrous oxide, yeah, or in terms of sulfur dioxide, yeah, or in terms of we call particulate matters, yeah. So there are certain catalytical reductions for these gases is taking place, and in terms of these SCR, which is important for selective catalytic reduction of nitrous oxide gases, there's a possibility actually to redesign even, such uh, uh, devices or filters, let's name them filter, so such filters can be very easily, actually one can devise them, yeah, or one can think in terms of devising. Then we have these particulate matters, so we call them ESP. This means electrostatic precipitators, yeah. So also there is a possibility that one can increase the efficiency, because the precipitator efficiency right now is around 98%, 99%. Yeah. And I have visited several cement plants. The precipitator efficiency in cement plant is not more than, at this juncture, above 90%. So even in cement plants, there is a huge scope actually in order to actually bin the collection, so-called, of these particulate matters. And then we have this FGD, which also reduces the sulfur oxide. So because flue gas desulfurification, sulfurization. So this flue gas desulfurization also, there is a possibility, because the efficiency of, this particular process is around 90%. Yeah. And then of course we have a stake, because in the stake also normally we have a tower, which is 100 meters high, so then we leave actually this particular gas in the atmosphere, and through certain processes, around 100 kilometers, sometimes 200 kilometers, sometimes 300 kilometers later, actually this gas is so-called being settled actually on the ground, so therefore we have to, although there are monitoring mechanism every year, so people like me who are experts in this area, so we visit, such monitoring, emission monitoring stakes, and we monitor each year, and we also give a certification actually to those companies. But still, what I feel that actually there is a possibility actually for all of us to do something very interesting and nice actually in this particular area. Next one, please. Yeah. My next talk is more into wastewater, and I would like to show you that why wastewater uh, is important for us. So when we say wastewater, this means wastewater is waste. So therefore it has to be thrown out. Now I try to bring one figure here. So if you see in the middle, there is a chart, yeah, and which on the y-axis shows the demand, water demand and water supply, and on x-axis in the middle, it shows the timeline, time axis. So it starts somewhere, let's say 2000, 1990, 2001, and goes until 2050. So Niti Aayog has prepared recently a report last year, recently means last year 2019, and they have given this kind of a data that per capita water availability and projected water demand. So when we say projected, means this is, it has been so-called assessed or estimated for the future. So this means if we know something in 2020 is the actual availability or actual demand, but when we want to know what will happen in 2030, 2040, 2050, yeah, so we use certain mathematics, we use certain interpolation techniques, and based on those interpolation techniques, yeah, we project for future. And so therefore some of these figures, beyond 2011 and 2016 are actually for the projected one. Okay, so if we see here, so I will like to request you to look left hand side, which talks about per capita availability. Now per capita availability is a function here of number of people. Per capita means number of people. Now you know that the population in India is increasing. Therefore, if X amount is there and if number of people are more, then availability decreases. Okay, so also what is happening that recently you must have seen that in India actually the rainfall is going down. Now the amount of rain in a given area is going down. This means per capita availability will decrease. So population is increasing, amount of water is supposed to come through rain is decreasing, therefore per capita availability will decrease quickly, right? So the projection for 2025 and 2050 is 1,341 and 1,140 cubic meter per year. Now, they have also made a projection. If you see projection for 2025 and projection for 2050 says that the projected water demand will be 1,093 in 25, but 1,447 in 2050. This means what is happening? Projected water demand is increasing and per capita availability is decreasing. And in the middle, this shows that approximately at 1025, which is point E, where demand and supply, this means availability and demand will be same, and that may come very close to 2032. Now in 2032, if my income is same, then my expenditures, I'm going to be in a big trouble. Okay, so we need to win new water. So the purpose of this is that new water. Now, if you see in our cities, currently the people living in cities will be almost 2 times because number of cities will increase. Also, people who are coming to cities, they are increasing. There's no harm in coming to city because cities are good centers for education. They are good centers for job. yeah, and they are also nice centers. So everybody wanted to come to city because of these inherent regions, and one cannot stop anybody, and like unlike China. So therefore, we have to prepare our cities well as well. So therefore, the solution actually lies right now in terms of wastewater recycling and reuse. So this means wastewater which we used to throw out, now it's no more a waste, it is actually a boon now. Yeah, so we can use that, yeah, and then we can so-called reuse that. And the work is happening at building level, it's also happening at housing societies level, yeah. And wherever the cities, I'm from Ahmedabad, in Ahmedabad, because the water availability is less, yeah, and water demand is very high, therefore we started very much actually treating and using these technologies. But it requires money. So money is the constraint actually. That's what I'm trying to write here. Yeah. So there's a possibility to look some of the so-called new projects into this area. I thought that I will give you a little bit further, what is happening. That if you see in our cities, small cities, there is no wastewater treatment plant. Even in Delhi, for example, right now they are just able to treat not more than 50% of their total capacity. 50% of wastewater in Delhi is actually being so-called flown in our Yamuna River. So, I mean, again, if such a problem is with a big city like Delhi, what about the small towns who do not have capability actually to work with it? Yeah. So therefore, there's a huge scope. And I wanted to say here, so please look this uh, graph, which talks about technology, ecology, economy, and society. I put this actually a graph for your understanding because it's not only technology is important, it's equally important for us is that the society, which will be using this technology. So the technology has to be developed in such a way so that society finds it useful, so that it is actually saving our economy. So this means it's a cheaper cost, and also it balances the ecology. Ecology means here environment and complete, I'm talking about complete ecosystem where we all live. Yeah. So we live, humans live, animals live, yeah, plants live, like that. Yeah. So therefore a balance is actually needed here, and therefore sustainability can be achieved only when we look into all those four parameters. So for you to justify your project into the area of wastewater treatment technology, I think you please look into these four dimensions. Do not look technology alone. Now, probable projects I have tried to identify. I thought that I would like to discuss with you, one project, but I think you can read that because the time is just 1 hour, it was not sufficient. But nevertheless, I think you can read that and we can discuss. So I try to list out some of the projects for you here. And one project, which is actually is on wastewater recycling and reuse. Now, when we talk about this wastewater recycling, recycling means we are again, bringing actually this wastewater to the standard, which is important. Either why World Health Organization has given certain water quality standards. Also, Government of India has given certain standards. Yeah, we call Central Public Health Engineering Organization. So that has given some standards. So those standards also can be compared actually. But we have to see that these systems are much more natural systems. This means they consider nature actually so-called for their uh, treatment. Also, what is happening that in Ahmedabad, the society in which I am living, we have a dual piped system. So this means, especially for bathing, cooking, and other users, we use actually the fresh water, while for flushing, we use actually the treated water. So this means we treat that water and we recycle and reuse actually into the flushing system. Yeah. So such things are very much possible. And also what is happening now is that people started talking about portable wastewater treatment plants. So for example, if having a single bungalow, yeah, then I can install a portable wastewater treatment plant, and then I can use the water actually mainly for gardening or for any other purpose rather than throwing that into the drain actually. Yeah. So such things are very much possible. And also recently government of India through Center for Science and Environment has given guidelines that each, for example, institution like university must have a wastewater treatment plant, and they must have a zero liquid discharge plant. This means you cannot throw actually liquid outside and you have to reuse actually that kind of thing. Next project which is possible, because when we will have this dual pipe system at building level and also let's say perhaps maybe later stage at a society level or a city level, then we require a supervisory control system. Yeah. Like it's like algorithm based systems, where you can so-called close, open, or close lace, or which area can be given first, which area can be given later. So we can have a demand dynamics, and based on that demand dynamics, actually, some system can be laid. So therefore, you can also look into projects, where if you can write a good so-called code actually in computer, I used to do actually when I used to research, and today also my PhD students are doing that. So you can also code actually a system, and then you can have those systems, and which is again a newness actually in those codings could be there. And then user to pay. So some sort of a system, when you have this SCADA system, then you can have a variable tariffs. For example, in Delhi, the Delhi government has said that if somebody is using less than 20,000 liter per month, he need not to pay even a single money. So such kind of a systems are very much possible when or can be regulated, when we have this SCADA kind of a system. Yeah. So it's like a joint computer civil system. So a lot of actually so-called this computer knowledge is coming into civil engineering, and this can be done only by a civil engineer, because many times computer people do not understand what is the SCADA system and what is the network and how losses are happening, and how to calculate the head and things like that. So even those who are intending to go for a higher studies, I think the intervention of computer is coming in each and every area, and therefore there is a possibility to do something based on that, especially for your city government. Yeah, so that could be also one of the interesting project even for our IS fair. Again, wastewater management, bioremediation is happening. So what is happening in bioremediation, that we are finding actually biological solutions. So this means we are taking plants, for example, putting plants in the wastewater, and these plants are somehow, cleaning that water. Or sometime, for example, there are plants, which can completely suck the water and make the area dry, so that kind of things can also be done. So what one need to do is that one need to identify the plant, one need to identify the test bed. Yeah, so a small area one requires, even kitchen also you can have, that kind of a thing. And then you see that whether, this project is scalable. Yeah, so therefore one need to identify really these plants, so there are many hairy plants which I'm showing you one of the example here, and therefore you can do the test bed, you can increase the distance, decrease the distance, whatever things you like, you can do them, and there is a possibility. In National Environmental Engineering Research Institute, NERI in Nagpur, actually they have such test beds available. I thought that I will bring one example but since I couldn't talk to one of my friend, Dr. Pawan, so I couldn't, incorporate one of those things. Yeah, but I think the literature is available, and in case you don't find that literature, you can ask Shreya Singh, or you can ask Sasha Kumarji. They can always, write me, and I can, send that literature, and I think you can read that as well. Yeah. The next one, please. Now, the another area which I thought that is water resource management, which is essentially important, for India, and because still we have at least 2/3 area in India as a rural area. We designate that as a rural area, and as you know that our agriculture is heavily dependent on rainfall, and that mainly so in the western India. So I come from Gujarat, and if you see here in Gujarat, Rajasthan, and also part of so-called Haryana, and of course Maharashtra, and then part of Karnataka, and Andhra is again, the suicides from Maharashtra are especially Bidar area, and also Latur and Ahmednagar area. They are very infamous, and I think when farmers are committing suicide in such areas, I think it's really a big problem. So we can also think about some solutions. Yeah. So I have given you this figure here in India, which is at the district level, so you can even pinpoint your district from where you come and what is the condition of actually how much deficit it is, and likewise. And also the other, I thought that I will also compare actually this with the urban area. So I try to bring our big towns, which India is having, and this data I got from Indian Green Building Council. The data which is left inside for district level, I got from Columbia Water Center, because Columbia University is doing a research work here in India. I have been a part of that research work. I mean, this data is from them. And the right-hand side data is from Indian Green Building Council, IGBC, which is one of the Center of Excellence of Confederation of Indian Industry, CII, based out of Hyderabad. And they have given this figure. And if you see here, Delhi, Mumbai, Chennai, Calcutta, Bengaluru, Hyderabad, each big city is in the deficit of so-called water. So somebody is deficit by 15%, the other one is deficit by, I said, 21%. Each city is under deficit. The demand is much higher than the supply. Now, we need really to go for, think for solutions, which I told you earlier, that we need to reuse and recycle actually the water, right? Now, when we talk about rural areas, happening that there are options, and many of us know very well, and many students, you must have visited actually one or other water harvesting structures, or in terms of a bow. Yeah, here in Gujarat, we call them bow. And we have actually built beautiful bow and ponds. If you see here, lakes, for example, Bhopal has a big lake, and Udaipur, and yeah, so each city has a lake. And in South India, especially in Tamil Nadu, if you see, we have an excellent system of actually having one pond connected with the other pond, and the water in these ponds had been used, for paddy cultivation. Again, presents a best example of actually water conservation. Yeah. So we can store water in terms of these tanks. We can store water in terms of ponds. We can store water in terms of aquifer. Yeah, and I will give you a couple of examples, how this has been done. Those who are from Gujarat, they know that, we have a bow system here, Ranini bow in Patan. We have again Adalajni bow here in Ahmedabad. So these systems are actually integrated groundwater recharge systems, and one can, they were never dried down. They were always actually having water. The only difference was that the water table was often going down. So we can have those storage kind of a thing. Then again, we have a water transfer schemes, which are bit new schemes. Of course, Sadar Sarovar Narmada Nigam Limited. We are bringing water from Narmada River. We are recharging here in Gujarat. We are recharging our Mahi River. We are recharging our Sabarmati River, and we are going further until actually the Rajasthan, and we are giving water through this limited canal. And then water recycle, reuse. And there are best examples, those who are from Mumbai, there's a factory known as a Rashtriya Chemical Fertilizer, RCF, So this factory, RCFI, this factory is using actually wastewater for producing urea. Also in Jaipur, we have a water treatment plant known as a Delavas, wastewater treatment plant known as a Delavas. We are reusing that water, wastewater, for agriculture purposes. Actually, in Delhi, again, those who are from Delhi, I can give you example like the area which is very close to Sarita Bihar. This complete area used to be actually irrigated by the wastewater treatment plant from Okla. Yeah, so such best examples are available actually, and I would like to take actually one or another. So I'm taking one rural example, and this place is known as Jhabua, which is the district headquarter of actually Madhya Pradesh, adjoining with the state of Gujarat and also Rajasthan. I did some research work here. So this area is actually, if you see here, the red lines, which are extreme right side, you see that these red lines are the variability. So area receive approximately 750 millimeter rainfall per year. And some years, actually, this rainfall is 1,200 millimeter. And some years, this rainfall is just 300 millimeter. So if you see the variability, there is approximately 300%, means 3 times more variability is there. So today, if my income, let's say, is 1 lakh rupees and I just receive 30,000 rupees, how will I survive actually? Yeah. So that's the big problem actually of water here in these areas. Although these areas, they have a very strong, rich tradition. It's tribal area, and I'm telling you, the people are so nice, and they are so pure with heart, and so really, and they have a strong, very strong cooperative practices. And one of the practice, they call it halma. Halma means, if somebody says that this is halma, means everybody is going to help that guy free of charge. The one important thing which I could draw out of the social understanding in Jabua was that, and there are certain NGOs who are working in this area, and they say that these people are actually very dharma oriented. Dharma generally means religion oriented. Dharma means they are the one who consider work as a worship. Yeah. So and then they consider paramarth, means helping others, is their prime duty. They also say that they are very swabhimani, who are independent, and also, swabhimani means they are very respectful, yeah, and swablambi, so they are also, independent. And since dharma, paramarth, swabhimani, and swablambi, when these kind of 4 things happen in anyone, that person becomes automatically, that area becomes automatically sustainable. So therefore, in Jabua area, sustainability was not a question actually till maybe 200 years back. And when, forest was exploited, when their animals were killed, when their lands were, taken, and when there was no water, the people's life, and then again I gave here J, Jan, Jal, Jameen, Jungle, and Janwar. So this kind of integrated system actually when we are having, then a sustainability actually will happen. Now what they have done in terms of water, so what they did actually, they have an approach which they call it actually ridge to valley approach. This means this is the GIS map which I have prepared actually, and you can see here that from top until the bottom, this means until the river actually, and you can also see in these figures which are there that some of these techniques were used in order to reduce the flow of water in these areas. And since water flow was reduced, the water halting time was increased. This means if you increase the water halting time, what will happen? The water start going, recharge into the groundwater. And this is precisely the problem that majority of our cities are facing today. You see, Jaipur is under immense flooding. Not Jaipur, I think all the towns. Delhi is always under immense flooding. Mumbai, I don't know what kind of engineers we are, what kind of decision makers we are sitting, that we are unable to solve consistently the problems which are occurring actually in our cities. And so you see in the rural area, they started actually developing this kind of water conservation and water harvesting techniques. And not only that, as I told you, that people, they do the halma, so they come together for helping others. Now in cities, we have lost that tradition of helping each other. So therefore, I think there is a possibility to revisit these technologies and see the implications and viability of these technologies under the city conditions. So some of the students can think of working and showing some of the models of that. Another example, I want to bring it to a beautiful city of Bhuj, actually, which is very close to our Pakistan border. So Bhuj city, almost 450 years back, if you see, this Bhuj city was having an elaborate water management system. So they were taking water, a drop which was flowing from the, let's say, hill, used to come down a little bit. There was a dam. Yeah, then further there was a dam, and then further, and then finally the water comes to the lakes. And not only one lake, it comes to a number of lakes. And if you see here, I'm showing you that the rainwater collected in a series of lakes. So we have a Dhobi Lake, we have a Hamirsar Lake, and then we have a Sagar Lake. Now you see that the cities were built in such a way. I mean, this Bhuj city is very, very old city. May not be at the time of Dholavira or Lothal, but this is also pretty old town actually. Maybe at least 2,000 years old. Yeah. So if you see that town, I mean, what is happening? That these towns were situated, somewhere on a such a condition, where you have a geology. So you see here, left hand side, I put a geological map of that area, and there are faults actually. And then you see that the underground slopes, overground, lakes are built in such a way, so that everything actually at the end falls on, on that fault. Yeah, and so therefore water, because this layer is an impervious layer, and therefore water can be very well actually stored. Now the population has increased. Since population has increased, then we need to think about some degree of technologies for here. Now, one degree of technology which is very important, and since this is a computer era, and I do a lot of actually computer work and modeling work, and therefore what I'm thinking that some sort of a locational enabled water database system. So if we know that how much water is in which lake, and how much water will we at the end of 1 month, 2 months, 3 months, 10 months, 1 year, therefore we can know, and if that information is available, then we know that how to use that water. Yeah, so that knowledge system actually we have to bring in the natural cycle. And those who are good in perhaps, in computer, they can think of having certain degree of applications. Yeah. So this means applying computer to the natural systems. And once you have a better understanding of those natural systems, it is much easier actually to so-called to predict the behavior of those natural systems. Like conservation and cleaning could be one. Yeah. And again, for example, floating boat, so if wind, blows, and this boat goes into from one side to the other side, and automatically, and if the wind direction changes, it comes, so self-cleaning kind of a system actually can be also installed. Some of you can think based on Archimedes principle. Yeah. Flow measurement sensors, for example, we can install at various levels, places. Geological investigation devices, for example. Today, we calculate the electric conductivity in order to measure actually the so-called the geological profile. And tomorrow, maybe if you can think something else, some other parameter actually in order to build those devices. And those who are actually aware that even magnetic field, if there's a water, you have a high magnetic field. Yeah. So if you take actually that magnet in the area, yeah, and if the water is there, then this water attracts actually the magnet, towards. I mean, those kind of theories are dominant actually in the so-called rural areas and villages. So some knowledge, which has been there, I think one can also have that knowledge together with the technology in order to make new devices. Yeah. Next one, please. Yeah. So these were the technologies which I talked actually with all of you, and I tried that I should not give you much clue, but I should give you sufficient clue to do something by yourself. Yeah. And now, if you have to develop a project, what are the various steps which are essentially important for you to consider? And these are the 8 steps normally we tell our PhD students, and I'm also telling you these 8 steps. Yeah. So first step is to identify problem. Now, identify the problem is the best way I have done. I have shown you, I have shown you the water availability, I have shown you the numbers, I have shown you the demand, and based on number demand, I have shown you what is the gap. Now, in order to address that gap, in order to fulfill that gap, what kind of project is needed? So therefore, you can define actually the project scope based on this gap. So therefore, you have to go for extensive research work on the subject. Yeah. And once you go through that extensive research work, then you can so-called set your objectives. That my objective is to develop a device, which can measure electromagnetic field, something like that. So this is therefore important. Yeah. And then once you know that this is my objective, then you think that what will be the deliverable. Deliverable is a device, deliverable is an idea, deliverable is a sketch. What is the deliverables? Yeah. So therefore, you see those observations and then see into the deliverables, means possible problems. Right? Once you know those deliverables, then you have to define that these deliverables by what time. This will take a month, this will take 2 months, this will take 6 months. Yeah. So like that. So therefore, you decide so-called your milestones for the given project. Yeah. And then what you do is that then you look for various solutions. And you say that best solution is the best one. So maybe you have 3 solutions: solution A, solution B, solution C. So it's not only one solution. Actually, engineering is never one solution. So it's not that physics problem can be solved only one way. No, it's wrong. A physics problem can be solved into 3 ways. Let's say if I want to measure the height of a building, I can measure the height of a building. Some say, okay, use barometer and measure the height of a building using barometer. So some guy can say that, okay, he will take a barometer, from the ground level, he will go to the top story, take a thread, put the thread down, put the barometer actually in that thread and measure the height and take a tape and measure the height. Yeah. Somebody will say, no, I want to look into pressure difference. Yeah. That what is the pressure here? What is the pressure on the top? Pressure difference gives me height, right? So One somebody will say that no, I will take the barometer, one time barometer, second time barometer, third time. So you keep on putting barometer until you reach the height. So there are so many solutions. What I want to tell that in engineering there are multi solutions. They are not even this solution is not single. Okay, so therefore you innovate and see that which one fits you well. And as I told you, look into technology, look into society, look into the ecosystem, yeah, look into the economy. And when all these 4 or 5 things are put, and it's fine. Today I have no capacity to buy. I have a capacity, let's say, to buy maybe Fortuna, but I have no capacity to buy Mercedes. So tomorrow, when my capacity increases or decreases, depending upon my decision, my decisions to be based on that. So therefore, we have to optimize those solutions. So optimization means that, and also you carry out risk, because it's very important that whether somebody has risk appetizer. If you say that no, your project fails, then you should not lose heart. I mean, it's okay, because you are learning, you are doing something. So that risk is very important. And if you are into prototype and you are not able to make product, doesn't matter, maybe next time you will make it. Yeah, so that risk assessment, and look into the likelihood that whether my project, what is the success, likelihood of success, and also risk is important. Yeah, so, and then once you have that so-called prototype built, you have product built, then you go for a patent of a project. Yeah, so my students, let's say, at least let's say PhD students, almost 50% of them, they go for patent. Yeah, so this means each year, one, or let's say each second year we get one patent. Yeah, so something of that it can be done. Now there are certain ethical issues. Next one, please. Yeah, so there are certain ethical considerations, and uh, because at this level there are not many difficulties. The only thing we need to keep in mind is that if something is done by somebody, please cite that and give it due credit. That's point one. That's an ethical issue. Yeah. So we call it plagiarism. Yeah. So we should not plagiarism. That's one. Unknowingly, if it has happened, then it's okay. But knowingly, we should not do that. Yeah. It's important. Informed consent. Yeah. This means if you are working in a group, always have to inform everybody. So, for example, if I am writing a paper, yesterday I have submitted a paper to Bailey, yeah, a publisher in Canada, and so I'm having 2 more co-authors. So I must tell them that I have submitted this paper. I'm the first author. Yeah. So transparency within the team is very important. And if somebody has given you data, then also please make sure that you take consent. Yeah, that you are using or not using. Yeah. And then whatever you do, reliability is very important. That if you have built something, how reliable it is. Is it 80% reliable? It's 90% reliable. And if it is 100% reliable, excellent. And also not reliable alone, also reproducible. Yeah, because in technology, reproducibility, because it has to come in the market, is very important. So therefore, it must be reproducible. Your results must be reproducible. This means today, if I'm measuring X things with a tape, then my tape must perform same after 1 year, or after 2 years, after 3 years, right? And also try not to use humans or animals. I have written animal here because don't do any experiment on humans or animals. Yeah, and if you have to do it, then please take a proper permission. Yeah, and then you can do that. Yeah. So with these words, I have ended my presentation. I once again uh, wish that I'm sure that you must have had a very nice understanding. And if there are questions, I will be very happy actually to take them. And as I told you that my email is also here. You can also talk to me. I also work with the Ministry of India Council of Technical Education, and they do have sometimes some fairs. So I do come as a judge there. But nevertheless, if there are questions, I will be very happy to answer them. I once again thank Shrey for taking me, through this presentation. Over to Shri.
Thank you so much, sir. It was a real nice talk, and we are delighted to have you to share your knowledge with the students on environmental engineering. So before we begin the Q&A session, I would like to play a small video for the students. This video has been prepared by the past alumni of students of IRIS.
Are you ready for the ride of your life? Well, it all begins right here. Your first step is picking a category you can enter by yourself or with a partner. If you are in 5th to 8th standard, you will be in junior category. If you are in 9th to 12th, you are in senior category and have a chance of making it all the way to ISEF. Now that you know which category you are in, it is time to find out which subject your project comes under.
At IRIS, you have a variety of 21 subject categories to choose from, ensuring that your project has a category that fits. The categories include animal sciences, behavioral and social sciences, biochemistry, biomedical and health sciences, biomedical engineering, cellular and molecular biology, chemistry, computational biology and bioinformatics, earth and environmental sciences, embedded systems, energy, sustainable materials and design, engineering mechanics, environmental engineering, material sciences, mathematics, microbiology, physics and astronomy, plant sciences, robotics and intelligent machines, system software, and transitional medical sciences.
A display shows the public and the judges what you have done. You're looking to attract and inform visitors about your project. To make it easy for people to access your results by creating a clear, attractive and concise display. The focus should be the work. Take a look at this reference.
Your title should be simple and must accurately represent your research.
Take photographs or videos of important parts or phases of your experiment to use in your display.
Prepare a miniature of your model in case your prototype is too large to be carried along.
Make sure your display is logically presented and easy to read.
Use neat, colorful headings, charts, and graphs to present your project. Pay special attention to labeling.
Be sure to adhere to the size limitations and safety rules when preparing your display.
The IRIS journey begins with registration on the website www.irisnationalfair.org with submission of online synopsis and supporting documents. These entries are prejudged by the IRIS Scientific Review Committee, and shortlisted projects are sent an email inviting them to participate in the IRIS National Science Fair. Winners of the IRIS National Science Fair qualify for an intensive series of mentoring camps and get the opportunity to represent India at platforms such as the Regeneron International Science and Engineering Fair in the United States of America. ISEF is the world's largest pre-college STEM competition. Over 265 Indian students have won over 160 awards at this competition. competing with over 6 million high school students from all over the world each year. Not only are you getting a chance to make your nation proud, but if you're lucky, you could join the 31 Indian students who have had minor planets named after them.
So guys, please don't miss this opportunity.
It's your turn now.
If you're innovative and you really want to bring about a change in the world, I think IRIS is the right place for you.
If you enjoy science and math and computer science and so on, so I mean, it gives you a platform to show what you've done, and you have a chance to go to ISEF too.
If science actually kindles your curiosity and you're really passionate about it, IRIS provides you the largest platform in India to show your talent.
Applying to IRIS, not only get to have a great experience, you meet great people and great mentors at that. They're not judges, they're not judging you, they're mentoring you, they're teaching you. They make you learn new things.
In the end, it's not about winning or losing, it's about experience, and IRIS National Fair guarantees great experience.
Don't tell people what your dreams are. Show what your dreams are through IRIS.
It's once in a lifetime experience.
It's your turn.
It's your turn. It's your turn.
It's your turn. It's your turn. It's your turn.
It's your turn.
Thank you so much. Uh, Now we will begin the Q&A session. May I request Sasha to students to please send their questions on the chat box, and my colleague Sasha to read out the question to sir.
Our first question coming in today is from Ayushman Sahu, who writes, his doubt was that plants react to our emotion. Means if we treat them nicely, they will grow. So the question is to Professor Singh. As to sir, what do you think about this? Shrey, is sir there?
Yeah, well, I do agree with Mr. Sahu that plants do have emotions, and but I am not a plant scientist or physiologist, so plant physiologist. So I think much I cannot say. Thank you.
We have a participant who has raised her hand. Sandhya, I will now unmute you and you can ask sir your question. Sandhya, please unmute yourself and ask sir your question.
Yes. Okay. Am I audible?
Yes, you're audible.
Good afternoon to all. Sir, my question to you is that you have shown us wonderful projects in terms of air pollution and water pollution. But sir, like the projects what you discussed with us, that cost a lot. And of course, these projects have been carried out by the students at university and college level. So, sir, I just wanted to know that is it possible to have a small prototype of these projects at a school level if we can work with our students?
Sandhya, I don't think that nothing can be done by these students, point one. So there's nothing college, there's nothing, so I'm 100% sure that any project which I'm showing can be very well done by these students as well. So that's point one. And of course, there are many projects, which can be taken, and certainly actually we can prepare a list as well, and then we can circulate to these students. I will request Saksha to please, take a note of this one, and we will certainly, give those projects to these students as well. So maybe one additional list, I think we will circulate and they can do. But here there is nothing, big which these students cannot do. Believe me, I'm telling you.
Thank you so much, sir, because we have worked in our school on a project, namely biofuels. What the slide you had shown us that because of burning of fuels in the nearby areas of Delhi, air is getting polluted over there. So we tried making the project over there, but due to many hindrances and to our limitations, we could not work more. So when I saw the kind of work you have shown us, that really motivates me to carry on the project once again.
Yeah, so, Sandhya ma'am, I will request you that you please try once again, because many times what happens that, we do not get time, or, sometimes students get busy and sometimes something happens. But please never, my point is that underestimate the power of yours as well as the students. And in case if you feel, and if Shasha and Shreya, they are, Shrey, they are okay, I can also help you out, in doing some of those projects.
Thank you so much, sir.
Absolutely okay, so it's no issue.
Thank you, sir. Thank you so much.
Welcome.
There's a question coming in from Dr. Yogendra Kumar Kothari for Team Iris. Sir writes, during COVID period, how can you conduct the event? So this is something that the IRIS team has been mentioning webinar after webinar, that and according to the IRIS cycle, the IRIS National Fair takes place in December and January. So we still have a very long time to go to determine whether we're going to have the fair in person or whether it's going to be a virtual online fair. However, we are proceeding with the submission process and pre-national fair evaluation as scheduled, and we will be putting it up on the website when it is time to decide whether or not we're going to have the fair in person. A lot of COVID vaccines do seem to be in the pipeline, and hopefully by then we should have something that will permit us to have the fair in person. Ayushman Sahu, you have your hand raised. I will now ask you to unmute and you can ask Professor Singh your question.
Good evening, sir. Sir, am I audible?
Very well, Ayushman.
Sir, I had a project that we can store water in plants. Sir, what do you think, sir? Sir, the water will be nice when we will store it in plants? Sir, and will it be equal to the roof water harvesting which we do, or it will be much better than it?
No, I mean, the putting waters in plant in order to, means so-called remove certain metals and certain impurities from water. It's very old, actually, Indian technique. We have been using, this technique almost, I think, at least 3,000-4,000 years. So this is absolutely no problem. I mean, so you can use that. The only problem with this bioremediation comes that the volume of water normally becomes either half, or if sometime it becomes, let's say, 60%. Yeah. So this means you lose a lot of water actually. So in case if there is a problem, and then you should use the other methods. But for example, if you're living in Orissa, where the water is much more available, then it's absolutely okay. And there are examples in Orissa there where they have used actually plants for treating the water, wastewater.
Yes, I was thinking of storing the rainwater in the plants.
Rainwater in the plants?
Yes, sir.
Okay.
Sir, like in the hollow plants we can store.
Yeah, but then again, what happens that, let me tell you, Mr. Sahu, what happens that Ayushman, that plant normally respite more water. Respite, you understand? So one process is respiration. Yeah. So this means plant drink water, and if the temperature is high, then they evaporate this water directly actually in the atmosphere. And this rate of evaporation could be as high as, let's say, 4-5 millimeter, yeah, per day. So have you understood me? So this means each day, I mean, it's like almost like a lake. Yeah. So if you have a lake and if you have stored the water, and if the temperature is, let's say, 45 degree, then the evaporation from lake is approximately 4-5 millimeter per day. And if you have plant, and these plants will also throw a lot of water into the air. So I don't think that this should not be a good idea. I mean, if your water is actually limited, and but then how will you take out water from the plants, Ayushman?
So I was thinking of some after the water is stored, so we can. So I was thinking to make a hole in that and use it.
I would just like to stop you over here because at the end of the day, this is a public platform, and we would request you to refrain from sharing any ideas that you may use towards the development of your project. You can get in touch with the IRIS team on contact@irisnationalfair.org, and we will get you in touch with Professor Singh if you have to discuss anything that is pertaining to a project idea with him.
Yeah, Aishman. So I think it's a very good point. Shasha has mentioned, and I appreciate actually that ideas are always very valuable. So really keep them very close to your heart. And also, while we are doing a lot of patenting, this is always told that your idea you should never share until and unless this is not registered. And registration process normally take 18 months. So I think I appreciate the view that Shasha has given. Yeah.
Participants, if there are any more questions for Professor Singh.
Great. I think so. I'm sure that they must have got good points. And so if there is anything further, Shasha, then you can send me email, and I will be very happy actually to help further. Okay.
Certainly, sir. Thank you so much, sir, for today's talk, and we'll be in touch again. And
I will request. I will do one request to you that please send these transparencies, because they are with you, to all the participants.
Sure, I will do that, sir.
Let they be available, so that at least they can refer some more time, and they can, because it is.
In any case, sir, the video, the recording of this session will be available on our website, so a student can refer to the presentation whenever they want.
Excellent. As you wish. Thank you.
Thank you so much, sir, and thank you so much everyone for joining today. We will wrap up the session now.